Let me go to the next slide. Okay, now one of the things which I always talk about is, as technology people or as scientists, as engineers, sometimes we get stuck with our technology because that is what we are experts at, and we concentrate only on the technology. Now, in order to commercialize, we have to realize that there are two other very important pillars of this process and product innovation phase, which we don't normally think about too much. We may not be experts in those fields, but we should make sure that we keep these two things in mind, because they are the ones which will tell us which ones will be successful products and which ones may not get that much traction. So one of them clearly is economics, the cost, the feasibility, the operational cost, as well as the capital cost. And equally important is the policy, especially in the area of water. Policy plays a huge role. So let me tell you a little bit about the story of Singapore and how Singapore has evolved in terms of water. Now, some of you may already know this, but in the 1960s, Singapore was literally a third world country. In fact, at that time, Singapore was the world's largest slum. It was bigger than Dharavi, it was bigger than any other place. And from there, the way they have come to what you see in 2018, this photo was taken a few years ago, is really phenomenal. Now, one of the things which they had to always face a challenge on is water. Clearly, it's a small island. It's a very densely populated island. There are around, it's 720, 730 square kilometers. And in that 730 square kilometers, there are around 5.5 million people living over there. And they have always faced problems with water scarcity. Now, the sad thing is that they get a lot of rain. The amount of rain which we get in Singapore is around the same as we would get in Mumbai or Gujarat. It's around, or I shouldn't say the whole of Gujarat. There are areas in Gujarat which are very dry, but at least on the west coast, we get approximately 2,400 millimeters of rain per year. So if all of that rain could be stored, then we would have more than enough rain or more than enough water in Singapore. Sadly, that is not the case because there is no place to store this. There are a few reservoirs, but it is impossible to store all of that water. So much of that water flows out into the sea. What we try to do is to mitigate now, clearly, if we don't have enough water just from rainwater, what else can we do? So one of the means of water is imported water from our neighbor Malaysia. There are these big pipelines which bring water from Malaysia. So that, but of course we are dependent on our neighbor for that. The third one is what you see as new water. Now new water is basically recycled domestic wastewater. So all the domestic wastewater in Singapore is collected, it is treated, and it is treated to the point where not only is it good enough to drink, it is actually too good to drink. Now, what do I mean by too good to drink? It certainly meets all the standards, but it doesn't have enough salts in it because we use reverse osmosis for the desalination process. And hence, if we have to use it directly, we would actually have to add salt to it, which kind of defeats the purpose. You purify it too much, then again adding salt. So they came up with a very innovative way of putting enough salts in it so that it can be used for potable use. What they do is they take a certain portion of this new water and they put it back into the reservoirs. So in the reservoirs, it mixes with the rest of the water in the reservoir, picks up the necessary amount of salts which are required, and then gets a second purification stage. So it's indirect potable reuse. The majority of this new water goes for industrial use. Why is that? Because there are some of the industries over here which require very, very pure water. Among them is microelectronics. So Singapore has a very vibrant chip making industry. Hard drives are made over here. There are a lot of big companies like Seagate, Global Foundries, etc. And they require what they call ultra pure water, UPW. And they, of course, have their own purification even beyond this, but the starting point is also very pure. So most of the new water which is generated goes for industrial use. 5 to 10% goes back into the reservoirs and gets blended with the rest of the water and goes through a second purification and then comes into the homes. The fourth one and the most challenging one is the seawater desalination. What you see there is desalinated water. Now, this is of course something which is an infinite resource, but it is also very expensive. As all of you know, when we do reverse osmosis, we are basically going against nature. And because we are going against nature, we basically have to provide the energy to overcome the osmotic pressure. And which is why this is the most expensive way of water among these four. Okay. And we are anticipating that by 2060, if we don't have any imported water, then we might have up to 55% of new water, which is the purified domestic wastewater, and 30% of seawater desalinated water. And I'll share a little bit about the efforts which we are making to reduce the effective cost of the desalinated water. And water research and technology have always been a national priority because of all these challenges. And our first Prime Minister in Singapore, whose name is Mr. Lee Kuan Yew, he has, of course, he passed away a few years ago. He used to say that when we talk about policy, all other policies have to bend to the knees when it comes to water, because without water, you can't do anything. Everything else, food, economics, everything else gets a secondary look. First is water. And that is how important water is to Singapore. The other big challenge which we have is solid waste. Because whatever solid waste is generated in Singapore currently, we do some recycling, but most of it, the bulk of it, goes into incineration facilities, which I have not showed over here. From that incineration facility, we get what we call bottom ash. And that bottom ash has to be landfilled. So this is the last landfill which we have. It's an island called Semakau. It will be full by around 2035, which is not very far away at all. So since I'll be concentrating mostly on water today, let me spend a couple of minutes to talk about what we are doing in the area of waste management or solid waste. So as I mentioned earlier, the easiest thing to do would be to say, okay, take the bottom ash and reuse it for construction purposes, some of the other purposes. And to some extent, that is possible. But there is also a lot of treatment which has to be done beyond having the bottom ash over there, beyond the incineration. So it is economically a little bit difficult. So these days we are looking at a demonstration scale at a technology called high temperature gasification. And basically gasification leads to lower amounts of the bottom ash, which is called slag. And this slag, because the treatment has been done at much higher temperatures, is now more amenable for reuse, and hence is able to be used for at least for road construction, etc. And we are currently looking at its feasibility to go into actually building construction and things like that. Now, just like new water, it has been branded as new sand, because sand can be used for construction. And of course, Singapore being an island, we don't have that much sand also. So we have to import sand. And many of the neighboring countries now are saying, hey, we require sand for our own construction. We are not going to give it to you. So if we are able to use this slag from the gasification, then it has a huge advantage, because we are also solving our construction material challenge from there. And it's truly like a circular economy where you are going cradle to cradle instead of cradle to grave, or, when we do the life cycle analysis. So it is truly a circular, this one, which we are trying to do. The other advantage of this high temperature gasification is that the old ash, which has traditionally been landfilled in this Semakau landfill, you can actually excavate that, bring it back, and subject it to gasification. And when you do that high temperature gasification, the volume goes down by half, and that also becomes slag. So this is the way we are looking at the solid waste problem. But most of my talk today will be on the water side and the membranes side, which I use for purifying the water. So going to the next slide, This is in short our SGMEM, which is our membrane consortium. So let me tell you a little bit about this consortium, but let me start a little bit backwards. Let me go back a few steps and mention how some of these things came about, because everything you see over here has happened since 2016. When I was working with GE up till 2015, I was leading the Water Research Center in Singapore for General Electric. And at the time, I used to get a lot of inquiries from the government agencies asking one very simple question, saying we have really good universities in Singapore which come up with a lot of inventions. How come industries are not picking up more of those inventions, licensing them, and then taking them to products and processes? And one of the things which not only me, but all the other industry directors all told them was that though the inventions are really good, they are very early stage, because obviously universities will take them up to the invention stage. After that, they said, since they are so early stage, it's a big risk for any company to take it at that stage, unless it's a really groundbreaking technology, then that's different. Otherwise, for other technologies which are very good, it's a big risk for the company to take it and take it all the way to full scale, especially in a field like water, where it is very risk averse, because water goes into our bodies, etc. So that is why the industry is extremely risk averse. They want to make sure that the technologies which are there are very reliable. And that is where the decision was made to come up with this national entity called the START Center, which you see on the left-hand side over here. And I was with GE at the time, and they said, so how do companies do this process? How do you do the de-risking? So I said, in companies, one thing to realize, first of all, is that this so-called translation process, where we take inventions and take them to products and processes, this is basically a process which requires different types of equipment, 2, different types of skill sets, and 3, most importantly, different types of thinking. You have to think on a systems level now. You cannot think about at the inventive stage as a single item. You have to think about the whole system which is going to be doing the purification. And so I said, companies, of course, have dedicated teams which do this kind of work. And to my surprise, this is how things move in Singapore. A few weeks back, a few weeks after having this conversation with them, they invited me for dinner. We used to, catch up over time, how the research is going, etc. And they mentioned at that time, what, that idea which you had given, we have decided that we are going to do it at a national scale and have a national translation center. And so I said, wonderful, I'm very happy you took that idea, and good, any advice you need from me, certainly I am ready to give. They said, what we are looking for is not advice. We want you to leave GE and come and set up and start this center. So initially I was a little doubtful, because I had been with one company for 15 years. I had been with GE Plastics, then I came to GE Water in Singapore. And I was a little reluctant, but they said, how many times are you going to get a chance in your life to set up something like this from scratch and then see it grow and, prosper? So that is the thing which really attracted me. And I said, yeah, they are right. I will really not get a chance like this. So that is how this START Center was established. And I will talk in detail about what the START Center does and how we do this translation and innovation process. But let me first briefly give you an idea of how we have set up this consortium. If you recall earlier, I had mentioned that there are 3 pillars. There is technology, which I have put here as T. There is economics, which I have put as E. And there is P as policy. Now, policy flows through the entire thing. Policy goes throughout, which is why having very strong government support for these kinds of activities is extremely important. And we do have that. Just like in India, there is a lot of emphasis on research today. Similarly in Singapore as well. And so the way we set up this consortium is that we have the research layer, which is the universities. You see the 2 older universities, that is NUS. NTU is relatively new, but it's still among the more established universities. There are 2 other universities, Singapore University of Technology and Design, and the 4th one is Singapore Institute of Technology. They are relatively new, but they also have some bright faculty who are upcoming. And so we have decided to involve them in this consortium as well. Then on the innovation layer, which is the translation layer, we have the Start Center, of course, and we also have an organization called Environment and Water Technology Center of Innovation, that is EWTCOI, and it is at Nian Polytechnic. So here the polytechnics are extremely well funded and they are very good, and they work on a lot of applications areas. So EWTCOI is in the applications area, and which is why we collaborate with them. And the third one is something similar to our India's CSIR. There is something called A-STAR, Agency for Science, Technology and Research. And they also have a lot of these commercialization, translation types of activities. They have different labs over there which are involved. The next thing we came to is the industry layer, because obviously when you are trying to commercialize all these things and having an umbrella organization, you need to pull in industry. And all of the companies which you see over here, they are all paid industry members. Now, there are a few new members. Sorry, the slide is a little bit old. Right now, we have around 30 people, 30 companies which are involved, and another 4 or 5 are joining us next year. So how did we choose these companies? Now, the obvious thing to do would be to say, okay, this is a membrane consortium. Let us look for membrane companies or affiliated to membranes and just get them all over there. And certainly we did that. But in addition to this, what we thought is, let us cast a broader net and have more of an umbrella type approach. What do I mean by that? We reached out to companies like Arkema, BASF, and they joined us as suppliers of the chemicals which go into membranes. So we have the suppliers that come into the membrane area. Then we have the membrane companies, as well as the companies which provide some of the services. So there are small and medium enterprises over here. There are also big companies, of course, which you see over there, which are involved. There are some very innovative small companies, which are startups and spin-offs, which are also involved in this. And then most importantly, because we have to make the business case for this, we also invited end users of membranes. So they are in no way membrane companies, but Shell from the refining side, Pfizer, of course, from the pharma side, and PepsiCo from the food and beverage side, they are all users of membranes, heavy users of membranes. So which is why we wanted to get that perspective, and we managed to convince them to join the consortium as well. Of course, this is all partnered through the government agencies and an organization called Imagine H2O, and it is sponsored. The funding comes from the National Research Foundation. Now, how do we manage this entire system? We start with, of course, the materials, as I mentioned earlier. Then we have the membranes. We take them to systems. We test the applications. And then we also have the end users, who are the 3 companies which I showed. But it goes broader than that. Those are not the only 3 areas which we live in. For instance, end users could also be the water agency. So PUB is also very much involved over there. And a lot of other companies who may not be formal members are also affiliated with us. These are just roughly some of the areas which we go into, which you can see over here. I don't want to go through these individually, but these are all areas which involve membranes. Now let me come to the Start Center, which is basically one of the components of the consortium. Now, my role in the consortium is currently I am the chair of the steering committee of the consortium. And most likely from next year, I'll become the managing director of the consortium. Right now, I have a program director who runs it for me. But starting next year, I will be taking charge of that. I will probably be getting a few more. We are expanding the consortium as well. So I'll be not just chairing the steering committee, but taking an active role in running the consortium as well as the Start Center starting next year. As you see over here, we also work with the universities and with several of the companies. So sometimes Start also does projects directly with industry, because there might be some small industry which has some good ideas, but they don't have the means to test those ideas or to scale them up. So Start comes in over there as well, because it's a national entity. We work mostly with universities, but also directly with industry. And in some cases, we work with industry as end users or adopters of the technology. So some of these companies would be adopters of the technology which has been invented at these universities. That is our model. What are some of the facilities we have at the Start Center? And I would like to invite all of you, if you ever have a chance to come to Singapore, please do come and visit the Start Center. It's a national facility, so I would be more than happy to host you. We have the means to make flat sheet as well as hollow fiber membranes at an industrial scale. Now, all of you may not be from the membrane field. Those in the water field will probably realize what these mean, but flat sheet membranes are easier to understand. There's basically a backing on which we put a first coating using the phase inversion coater. And then the main one is the thin film coat, where you see Ms. Go, who I showed earlier. She is basically running the TFC or the thin film coating machine, which is where we can change the chemistry and make it a nanofiltration membrane, reverse osmosis, forward osmosis, pressure retarded osmosis. We can do different kinds of membranes over there. And then there is a post-treatment line. If we want to stop the membrane at microfiltration or ultrafiltration, then of course we can go directly to the post-treatment. But those are very commodity ones. So typically we go for innovations in the areas which you see on the TFC line, the thin film coating line. Now, when I say industry scale, the roll which you see over there, it is 1 meter wide. So this is like a huge line, which is at full industry scale. But we have tweaked the design so that we can do different types of chemistry. Typically, a manufacturing line will be meant for one product, and it will make that product as efficiently as possible. Ours has that capability, but the way we run it is so that it is more flexible, that we can do different kinds of chemistry and get different kinds of products. After making these membranes, just the membrane itself is not what is going to go into the final application. What we do is a thing called element rolling, where we can make 2-inch, 4-inch, 8-inch elements, depending on the final use or the final application. And we have the ability to do that. After making the elements, we also test them. I'll come to the testing in a little bit, but first let me take a segue and go into the other type of membranes which we make, which is hollow fiber membranes. These are literally like small fibers. When my daughter, she was very young when we first came to Singapore, and she looked at these. She was 7 years old at that time, and she said, "Daddy, these are spaghetti," and they really look like that spaghetti, which is that pasta. But imagine the same spaghetti with a hole going through. So it is like these very thin straws. So basically, you can either filter the water outside in or inside out through these straws. And that is what these membranes are, which you see my colleagues on the right drawing over there. This is also done on an industrial scale. And if you see the upper right corner, there is a drum over there. And this drum, which is over there, has these membranes wrapped around. And the circumference of this drum is 2 meters. So basically, all of these fibers at the end of the run, you just chop it at one place, and most of the fibers over there will be full 2 meters in length, except for the first run and the last run. Those might be a little shorter, but all the other fibers, which will be maybe hundreds of fibers, will all be 2 meters long. And then we can take these and then chop them into whatever size we want. Again, here we have the ability to build modules. And these are built by a process called potting, where we can do horizontal potting or centrifugal potting. We can also do vertical potting. And after that, we trim these modules, and the modules are ready for testing. We have the ability to test all the way from a small scale all the way to full scale. What we mean by full scale is 8-inch diameter and 1 meter long for both hollow fiber membranes as well as for flat sheet membranes. Now, this is just the middle step. Now we have made the elements. After this, what do? We have to actually design the system. If you recall earlier, I mentioned that you cannot just stop at the membrane stage. You have to take it to the element stage, but then eventually you have to think in terms of systems, because the system is the one which will eventually get implemented as the actual product out there, and the process will be based on the system design. So we have people who have expertise in that as well and who design the systems for us. They are part of our team. Beyond the systems, what do? We do something called piloting. And that piloting is done again at full scale. So I've given you one example over here. PRO is pressure retarded osmosis. So let me spend, okay, I have a little bit of time. So let me spend a couple of minutes and tell you what is pressure retarded osmosis. As I mentioned earlier, when we are doing purification, we are doing reverse osmosis, which is why we have to pay the cost in terms of energy. We have to pay the penalty in terms of energy because you're going against nature and doing reverse osmosis. However, we have two sources of water, which I mentioned earlier. There is the new water, which is domestic wastewater, which has been purified. And we also have seawater desalination, so seawater which has been purified into water. Now, the pure water, of course, I talked about earlier, but what about the waste? The wastewater or the concentrated water, which is concentrated in the impurities, that typically would be put out into the ocean or the sea. So what we said is, why waste this wastewater? Let's take this wastewater, and we have two salinity levels. The wastewater from the domestic wastewater is definitely much less saline than the seawater. The seawater is a very high salinity as such, and after purification, it is even more concentrated. Now we let it flow the way nature intended. That is that the domestic wastewater concentrate now flows towards the seawater, because the intent is not over here to make more water or to purify more water, but to generate energy. And this flow, the natural flow of water through these membranes, is harnessed using different types of turbines to partly offset the energy cost of the overall desalination process. So this is one example of the kinds of pilots which we have done. Now we have gone since October of 2021, we have gone into what we call our second tranche of funding. And over there, the government gave us a big challenge saying, okay, you have done these translations, you have done them relatively successfully. Now we want you to work on items of national interest. And in Singapore, biggest national interest is water. So they said, within water, the biggest challenge which we have is the cost of seawater desalination. Typically, the energy cost of seawater desalination in the state-of-the-art systems today is between 3 and 3.5 kilowatt hour per meter cube. And the challenge which the government gave us is to bring it down to 2 kilowatt hour per meter cube, which is, believe me, a real challenge. Those of you in the field must be realizing how difficult a challenge this is to take seawater to these levels. Because if you think about it, remember I said that there is the energy cost of osmosis itself. That itself is 1.5. So all the other costs of operations you have to add and bring it to 2, which is a challenge. But we like to take up these big challenges, because if we take up these big challenges and we take up such significant numbers, then even if we don't reach 2, we are going to come close to it. Even if we achieve 2.5, that is a great achievement. So that is the way we think. Let's set a challenging target and then see how close we can push it, push the boundaries. This is an integrated validation plant which we are setting up with our water agency, and that will have 3 parts. There will be the pre-treatment part, there will be the filtration part, which I have put here as seawater desalination, and then of course there's the post-treatment or the polishing part. And all of these together, the overall capacity of this is 1 million gallons per day, 1 mgd, which is not just at pilot scale, it is at demonstration scale. So we have just taken over an old plant from PUB. In fact, we just signed the licensing agreement. The Start Center has taken it over from PUB. And now we are building up this desalination plant, and we will start testing by next year. And for the next few years, we'll be testing different kinds of membranes. Few of them you can see over here, but this is not an exhaustive list. Now coming back to SGMEM, which is the consortium. How does SGMEM work? SGMEM basically, as I mentioned earlier, starts with the universities, and then translates to the translating centers, or rather passes on to the translating centers. Now, the most important thing over here is TRL is technology readiness level. And depending on the stage, which you can see on the upper right side, depending on the stage of the technology, we put different technologies at these different levels. Now, technology readiness level of 3 to 4, which is going from proof of concept at the bench scale to then modular design and scale up. This is a very important piece because this is where there has to be a very good handshake between the inventors and the people who are doing the translation. So suppose there is an inventor who says, okay, I have invented this. Here is my publication or here is my patent. Now I don't want to be involved. You go ahead and do it. That never works. We have to work very closely with the inventor, the professor or the researcher who has come up with this, for the simple reason that when we start translating, think about the different challenges. When we are scaling up the membranes are made in lab using these expensive, lab grade chemicals, Sigma, Aldrich, Fluka, and some of these. Then when we take it up in my start center, we are going to use industry grade and industry scale chemicals. So definitely there is this thing in translation. So you have to tweak a lot of things. Sometimes a process has to go back in the lab. They have to use those. They have to come up with some new process. Then it is bring back. It is a very circular process, and which is why there needs to be a very close engagement with the inventor, between the inventor and the translation organization, which is where it works best. Luckily, we have had very good collaborators, and we have successfully translated quite a few different technologies. Today, I don't have the time to go through all of that, but we have done things like membrane distillation, nanofiltration. We have quite a few areas where we have come up with new technologies and actually translated them to full scale. Of course, equally important is to then, after the translation, also collaborate with the suppliers, manufacturers, system integrators to make sure that it goes to the full system. Because at the end of the day, the Start Center and the other organizations, these are national entities. They are not manufacturing organizations. Eventually, it needs to go to a company, and the company has to do the final commercialization. As I mentioned earlier, we are going beyond water into all these different areas. And so far, we have 3 companies which are in these 3 fields. We are also looking to get collaborators in the other areas which you see over there. And next year, there will be companies which will be filled up on this side as well. One of the other things which we have been doing with this consortium is looking at frontier areas. What are the new areas which are coming up today where membranes could play a part? And you can see some of these on the left side. The hydrogen economy is one. Tackling carbon dioxide emission is another one. Waste to energy, aquaculture, end of life of membranes. What happens to these membrane units at the end of life? They go into landfill. So is there something we can do with them? Is there some way we can reuse some of them or repurpose some of them? And the last one is, of course, green membranes, which is basically we are first looking at, can the processes to make membranes be made greener? Then the ultimate goal is to make the membranes themselves green. So green membranes made with green processes. But this is a journey. It is like saying, fossil fuels versus renewable fuels. It is a journey from one to the other. You cannot just stop one day and then say everything is going to be. That doesn't work. Over several years, solar energy has come such a long way. Similarly, even for membranes, it will be a journey towards going towards, eventually towards green membranes, which is our goal. But it will take a number of years and number of inventions before we get to those. In the meantime, we have also done some symposia, webinars, workshops, and also we have participated in a lot of exhibitions. We have also done MOUs, very selective MOUs with certain universities which have kinds of expertise which are complementary or which we don't have in Singapore, because Singapore is a small country. It has only a few universities. So these are some of the universities with whom we have established MOUs over the past few years. Let me give you an example of a kind of event which we have, because this is not a usual consortium event. Typically in a consortium event, You will have a bunch of people who talk about the cutting edge research, which is great. That is something which we certainly have. But we go a little bit beyond that. What we did was, let us not start with the cutting edge research. Let us start with what are the needs for the membranes. So in this case, we invited someone from pharma industry. That is my colleague from Pfizer, who came and he talked about what are the membrane uses in pharma, what are the challenges which could use membranes. One of them clearly is for the wastewater, but also for the process. Can you do the pharma processes overall very much a batch process? Can you try to convert it at least partially into a process which is a continuous process? That would be a huge game changer for pharma. So those are the kinds of futuristic short-term and long-term goals for the industry. Based on this, a lot of people came and shared their expertise and what they have done. And then we always have a distinguished scientist who comes and gives a seminar. In this case, it is Professor Jerry Lin, who talked about membranes made from zeolites. So again, very futuristic, but we said, let's get people thinking about, what is the future? What are some of the things which we are going to do? So this is the way we structure some of the events which we have. Similarly, we had another symposium a couple of years ago. This is pre-COVID. And this is where we asked someone from refining, Shell, to come and talk. And then, of course, we had some of the other things discussed: market technologies, sustainability grants, digital platforms we talked about, and strategy. And then we had a keynote on ceramic membranes. In this case, that's Professor John Wang from the other university in Singapore, NUS, who gave a really excellent talk. And then, of course, in 2020, the great COVID came, and we pivoted online. And you can see some of the webinars which we organized in those days. But that was great, because before that, I don't think we had too many webinars. These webinars are almost entirely driven through COVID. And then beyond COVID also, we are doing so many things online, which is really great. Of course, in-person is the best. But if you can't have in-person, when you have people from a lot of different places or a lot of different countries, I think this is a great forum. And these are some of the different things which we have done over time. We have had different topics which have been presented at these different symposia. So with that, this is the website which we have for our consortium, sgmm.sg. Please note this. Please do visit the website. My colleague Joanne, who I showed in the second slide, she's the one. She and her team have actually set up this thing, and it's an excellent source of information for everything to do with membranes. And this is for anyone who would choose to scan the QR code, please feel free to do that. My email address is given over here. And of course, Professor Yadav has my contact. So please do feel free to contact me at any time. And thank you very much for your kind attention. And I'll be very happy to take any questions now. So please do let me know if you have any questions.
Sir, there is one question. Do you
Yes,
have a distributor center of these membranes in India?
No, so the membranes which I showed, they are all basically at the stage where they get commercialized through a particular company. So it would depend on whether that company has a center in India. But believe me, sir, these days, most of the major membrane people, they all have some distribution networks in India. Because India is a huge market, a lot of them have a presence in India, and they are any specific area which you are looking at, please let me know. I will put you in touch with the right industry, which will most likely have a presence in India as well.
Hello.
Yes, ma'am.
Yes. Sir, is it possible to grow the biomass on a membrane?
So this is a little bit outside my area of expertise, but we do have a lot of these bioreactors, membrane bioreactors. And so what they do is, my understanding is that they have, when you want to treat something like industrial waste, a lot of times, there are obviously these biological masses which treat those. And then after the treatment, the filtration is done using membranes, and these are called membrane bioreactors. So there are
Yeah.
quite a few companies which have access to these. And even at my university, NTU, there are people who are working in this area who are experts on the biological side, and then they will collaborate with people on the membrane side.
Yes. Because in India, actually, there are so many industries, they are going for MBBR technology
Yes.
because MBBR requires less space and industries are
Yes.
always having the
Correct.
constraints.
Correct. Correct.
That's why.
Yeah, so
Uh,
even in if you remember, ma'am, I also mentioned that we do domestic wastewater reuse and
hmm,
purification. So in a lot of those plants, for exactly the reason which you mentioned, which is the footprint is much smaller, and
yeah,
Singapore, of course, doesn't have so much space.
space.
So our PUB, our water agency, is steadily going towards systems where we are using MBR instead of the traditional methods.
Yes. And if we are means particularly, I think if we are using it for the industrial wastewater, then the life of the membrane will be very, very low. So I think for that, I think we require more and more membrane.
Yes. So so again, for most of these, the conditions under which we use these membranes, as you rightly pointed out, is very important. Now, industrial wastewater is challenging, and there are different means of treating that. So one is, of course, MBR. MBR is one of the clear ways it is. The other one which we are working on is also membrane distillation, because if you are talking about metal, heavy metal impurities, etc., sometimes we can use membrane distillation as well. So we look at it from, I know membrane distillation is not as common as MBR, but we look at that particular one as well.
Okay. So actually, sir, please do share that if anybody is interested in the that type of the membrane to be considered for the study for the industrial wastewater application, because we are mainly working in that particular area. So that will be helpful. Even at industrial people are ready to accept that particular technology if we are having some that type of the laboratory work or feasibility study.
Okay, ma'am. I'll certainly
Okay,
keep it in
thank
mind. Thank you.
Okay, thank you.
Um, if any other participants have any questions?
There was a question on the chat, 1 minute.
Uh,
So many times you say that RO system we do is against nature. It means, is it effects on life? No, 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 no. Please, that's not what I meant. What I meant was that the when we talk about osmosis, right, which is how our bodies also purify. Our kidneys use osmosis. All our cells use osmosis, and basically the way osmosis goes is that the dilute stream normally goes towards the concentrated stream. Now, when we do seawater desalination, we are doing exactly the opposite. You are taking a concentrated stream and you are pushing it towards dilution, which means you are purifying the water, which is what I meant is against nature. Nature likes to go dilute to concentrated. We are going concentrated to dilute. So that's basically what I meant. I hope that answers your question. Thank you.
Thank you, sir, for sharing the valuable insights about SG membrane consortium and its component as well as capabilities. I'm really thankful to you. All the participants are requested to fill the attendance, which is link for which is given in the chat box.
All are requested to turn on cameras so that we can have one photograph with Dr.
Sure,
Adil.
sure. Certainly.
Please turn on cameras. Ayushi,
Yes, sir.
please take the photo when cameras are on.
Yes. Thank you, everyone. Thank you, sir.
So
Thank you
at
so
the
much.
outskirts,
Yes, yes,
at
sir.
the outskirts, I thank Dr. Adil Dhalla and all the participants for remaining present for this a kind of unique lecture, and this will really help you, as Dr. Namrata has discussed with Sir, that the membrane technology can be taken up further in India, the way in which is dealt in Singapore. Thank you very much, sir. And thank you very much for your invitation
pleasure.
also.
Thank you.
Thank you very much for your invitation also. That
Sure.
any one
Please
of
do
you,
come.
when you, yeah, please, sir. Thank you, sir. Thank you very much.
Thank you. Bye.
Thank you, sir.
So participants, now we will meet at 6 p.m. Sorry, 7 p.m. So it's 5:53. Our next lecture will start at 7 p.m. So I'm not ending this meeting. I'll keep it as it is. If you are leaving, you can join again.